Hello students, here we are discussing rigid bodies and rotational dynamics. The major important thing is, so most weightage one and maximum number of students are facing difficulties from this chapter. Okay, so I'm trying to explain that concept to concept. So concept videos I'm making. So every video is 5 to 10 minutes only. Okay, so for the first one, here I'm talking about this, the first lecture based on this. So this is what is the difference between translational motion and rotational. First we are discussing translational motion. Translational motion means what? Simply it's a translation means dragging of a body, dragging of a body on straight line path or on a surface or a smooth surface, like, so on a surface means what? It should be like a straight line path. It's a straight line path. Yes, so this is what straight line path. So just imagine this is the body. This body is dragged over the surface. So for example, if I choose about the 2 points are these, like, okay, so these are the points. It's what? A, B and C. I'm dragging this body from here to here. So these particles, they have the motion along with the same straight line path. So the velocity of A, velocity of B, velocity of A, velocity of B and velocity of C. So these three of them, VA is equals to VB is equals to VC, means, so they are parallel, their motion is parallel, and velocity of A is equals to velocity of B is equals to velocity of C. Okay, so like is equal to the velocity of center of mass also we can say. So this is the first one. Now second, for example, for the second one more body I'm taking as it's an irregular shaped body, like, okay, the body has, I'm choosing these points from here, like, okay, so this is what? A, B and C. So their path is what? If they are traveling like, so their path is like a straight line path. They are parallel to each other. So this is what? Same velocity at A, velocity at B and velocity at C. VA is equals to VB is equal to VC. Okay, this is second. So this is about translational motion. Translational motion means what? Just only here we can say dragging of a body from one point to another point is the translational motion. So here we need to discuss the most important thing is that in translational motion, so in translational motion, each and every particle have same displacement in equal intervals of time. Okay, so in translational motion, each and every particle, so each and every particle has same displacement in a equal intervals of time. So equal intervals of time is the important thing to remember. So translational motion is just what? All the particles have the same parallel velocities and they have the velocities are same, and every particle, if they are moving from one point to another point, they have the equal displacements in equal intervals of time. So here rotational motion means what? If you choose any body, the body has to be rotated with respect to a point. For example, this is the body I'm choosing as this. It's any irregular shape of the body. So it has to be rotated with respect to this axis. This axis is called what? Axis of rotation. Okay. So if I choose the points from this, some different points, if I choose that, it's what? A, B and C. So their paths are what? Concentric circles. Okay. So they are concentric circles. So from this we can make them that. So what was the statement earlier for the translational motion? each and every particle has equal displacements in equal intervals of time. So here each and every particle, so this is what it's what A, and next one is B, next one is C. Okay, so just I'm choosing that there is one perpendicular line I'm drawing for this concentric circles. Every particle has the concentric circles, and one perpendicular line if I draw this one. Okay, so this is, and next one more line if I take on this one is along with this. So their angles are, so this angle, the A moves from here to here, B moves from here to here, C moves from here to here. So it maintains what? Equal angles. Okay, so each and here you can say each and every particle. So each and every particle, each and every particle, each and every particle has equal angular displacements in equal intervals of time. In translation motion, equal translational means what you say, equal displacements, linear displacements in equal intervals of time. So each and every particle so has equal angular displacements, angular displacements in equal intervals of time. So equal intervals of time. So this is for the first one. And for second one, if you discuss on this, so second one is every particle means what? These particles are there. So each particles can form. Okay, each particle in a body. So each particle in a body. So they have what? So they has concentric circles. Concentric circles. They have concentric circles. Yes. So different radii, but the center is what? Same. With respect to one axis, they are moving whenever body is moving. So you can know this one. Equal angular displacements in equal intervals of time. Angular displacement theta by t, which is known as angular velocity.